Hi, good afternoon, everyone. So in this video, I am going to cover ISI 2004 PEA question, and we will start from question number 24. Please read the question. It says there are 4 letters and 4 directed envelopes. The number of ways in which each of them can be put into a wrong envelope will be. So this is a question from de-arrangement. And whenever you want to de-arrange, the word de-arrange says that none of them is arranged in the right one, right? So whenever you want to go ahead and you want to de-arrange, the formula for de-arrangement is this: n factorial 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on and so forth. So in this example, as you can go ahead and see, we have 4 envelopes and we want to arrange 4 letters in incorrect ways in these envelopes. So I'm going to go ahead and I'm going to go in n till 4. So I will put 4 factorial here. And in this process, so this continues. So this is 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial plus 1 by 6 factorial and so on. So you will only go till your n. So in our case, the n is 4. There are 4 letters in this case. So I will go till n equal to 4. So I will get 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Now you just have to solve. So 4 factorial is going to give you 24. 1 by 2 factorial means 1 by 2. 1 by 3 factorial means 1 by 6. And 1 by 4 factorial means 1 by 24. So when you will go ahead and you will solve this, you will get the answer as 9 ways. So the correct answer to this question will be 9 ways. Okay, come to the next question. It says, if a square x square plus bx plus c has one root greater than unity and other less than unity, then what happens? So this is a good question. So try to understand that. First of all, I have 2 roots, 2 unique roots. So let those 2 roots be alpha and beta. And let us assume that alpha is less than 1 without any loss of generality and beta is greater than 1. I just have to get 2 roots, one less than 1, one greater than 1. Now this polynomial equation a square x square plus 2bx plus c, this can be rewritten actually. And because alpha and beta are 2 roots of this polynomial, I can rewrite this polynomial as alpha square x minus as a square, this a square, x minus alpha, x minus beta. So I can write this as a square x minus alpha into x minus beta. So I have written it like this now, right? These are my 2 roots, alpha and beta. Now what I want to go ahead and I want to do is I want to check the value of this polynomial at x equal to 1, right? Right. So if I just evaluate this polynomial at x equal to 1, what will I go ahead and get, beta? I will get a square, 1 minus alpha and 1 into 1 minus beta. I've written this polynomial like this. And now I want to evaluate this polynomial at x equal to 1. So when I will be evaluating it at x equal to 1, I will get a square, 1 minus alpha into 1 minus beta. Now try to understand that clearly we know that alpha is less than 1 and beta is greater than 1. So therefore I can say that since alpha is less than 1, 1 minus alpha will be greater than 0. And since beta is greater than 1, so 1 minus beta will be less than 0. And a square, because it is a square, will always be greater than 0. So what I have got from here is that this a square is rather positive. 1 minus alpha is positive and 1 minus beta is negative, right? So if I just combine the 3 things together, I will get that this entire term will actually be negative. This entire term will actually be negative, right? So this is now sure that this polynomial with 1 root positive and 1 root negative will actually be a polynomial which is entirely negative. So I've got a square x square plus 2bx plus c less than 0 when evaluated at x equal to 1. When they evaluated at x equal to 1. Right? Because when I evaluated it at x equal to 1, I got that this thing is negative. So I will just put the value. So a square into 1 square plus 2b into 1 plus c less than 0. So I will get a square plus 2b plus c less than 0. So the correct answer to this question will be, it will be none, it seems. Right? So it will be none of them. A square plus 2b plus c should be less than 0. This would be the answer to this question. Right? Okay. Come to the next question. So now this says, okay, so one thing that we can go ahead and also do is, no, I cannot evaluate it at any other point, because if I want to eliminate A from it, then B will also be eliminated. So yeah, none of them is correct, beta. That's the correct answer. Okay, come to the next question. This says you are given a sequence an is equal to 1 by n. Okay, and this says bn is 1 upon 1 by n plus 1, and you want to go ahead and you want to evaluate this. So try to understand, what do I want to evaluate? I want to evaluate the sum 1 from 99, an minus bn whole square upon an into bn. So if I were to find out an minus bn, an is 1 by n, bn is 1 upon n plus 1. So this will go ahead and give me n plus 1 minus n upon n plus 1. So if I just try to go ahead and I want to solve this, I will get 1 upon n plus 1. And if I do an into bn, then this will also give me 1 upon n into 1 upon n plus 1. So therefore, what I notice is that an minus bn is actually equal to an into bn. An minus bn is equal to an into bn. So what I can go ahead and do is, this will become an minus bn whole square, and an into bn will, an minus into bn will become an minus bn, and summed up from n equal to 1 to 99, and this will cancel out. So I will get sum from 1 to 99, an minus bn. Right, beta? Now try to understand that an is given to you as 1 by n, and bn is given to you as 1 upon n plus 1. So an is given to you as 1 by n, and bn is given to you as 1 upon n plus 1. And we need to go ahead and find the sum from n1 to 99. So I will start putting the values now. So if I put as 1, I will get 1 by 1 minus 1 by 1 plus 1. Then I will put 2, 1 by 2 minus 1 upon 2 plus 1. Then I will put 3, 1 by 3 minus 1 upon 3 plus 1, and so on. And my last term will be 1 by 99 minus 1 by 100. So what we will notice is, this will come as 1 minus half plus half minus 1 by 3 plus 1 by 3 minus 1 by 4 till 1 by 99 minus 1 by 100. So you will actually notice that all of these things will cancel out, right? Cancel, 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 cancel. These will all cancel out, and you will be getting 1, and you will have this last term only, minus 1 by 100. So this will be 100 minus 1 by 100. This will be 99 by 100. So the correct answer to this question will be C. That means 99 by 100. That would be the answer to this question. Right, beta? Okay. Come to the next question. So this says you are given that A is, okay. So you are given that A is 1, 2, minus 1, minus 2. And you're supposed to find out A to the power 100 plus A to the power 5. Let us try to understand this thing a bit, huh? So this can be written as A to the power 2 to the power 50. And this can be written as A to the power 2 into A to the power 3. So what I require will be A to the power 2 and A to the power 3. If I know that, then somehow I will get some information about how to solve this question. So try to see that when I will do a square, I am going to go ahead and get 1, 2, minus 1, minus 2 into 1, 2, minus 1, minus 2. And this is going to give me 1 plus, so 1 plus 1 minus 2 minus 1, minus 1 plus 2, 1, 2 minus 4 minus 2, minus 2 plus 4, 2. I will get a square as this. And if you notice now, if I just take minus 1 out, I will get 1, minus 1, 2 and minus 2. This is nothing but minus a. So I have found out that a square is nothing but minus a. A square is nothing but minus a. Okay. Now, if I just go ahead and I just find out a cube will be a square, that means minus 1, minus 2, 1, 2 into a. That means 1, 2, minus 1, minus 2. This is going to give me minus 1 plus 2, that means 1. 1 minus 2, that means minus 1. Minus 2 plus 4, that means 2. And 2 minus 4, that means minus 2. And if you notice, this is nothing but this is the value of a. So we have got that a cube gives me a and a square gives me minus a. Just for your for the sake of the completion, you can go ahead and find a to the power 4 also, which will be a cube, into a cube into a, right? So I will go ahead and find out this. And you can notice that this will come as 1 minus 2 minus 1, minus 1 plus 2, 1, 2 minus 4 minus 2, and minus 2 plus 4, 2. So you notice that a to the power 4 has actually come out exactly as a to the power 2, which is nothing but actually minus of a. And there is another way to check this out. So you can clearly see that a to the power 4 will be a to the power 3 into a. A to the power 3 is just a into a. This is a square, and a square is nothing but minus a. So what we have noticed is that whenever we will have an even power, then it will give me the answer as minus a. And whenever we will have an odd power, that will give me the answer as a. Actually, that is enough to solve this question. So now I even don't need this breaking up. This is an even power. Whenever I have an even power, it will give me the answer as minus a. And whenever I have an odd power, it will give me the answer as a. Minus a plus a should be 0. So the correct answer to this answer will be that it will be 0, 0, 0, 0. Right? So this is giving me the answer as minus a, which means that this matrix that would be created will be minus 1, minus 2, 1 and 2. And this matrix that will be created, it will be 1, 2, minus 1, minus 2. So if I just club this together, I will get 0, 0, 0, 0. So the matrix that I will be getting, it is actually going to be a 0, 0, 0, 0 matrix. Am I clear with it? That is the answer to this question.